Ho ho ho! Christmas is coming soon, guys, and I'm happy that I finished the KRELL amplifier. Yeah, was a bit of work on it to make it work nicely, and on the last stream we had the sound test, and believe me, if you listen straight away to the speaker, sound amazing. And on this video we're gonna do some measurements and some oscilloscope test and some spectrum analyzer. But before starting that, let me give you a small recap what I've done so far to this amplifier. So here we go, this was my first video on this amplifier. When I received all the parts that I needed to start with, because I had a problem with a few FETs that are obsolete and they was burned out, and I went to lots of data sheets. I spent, I think, maybe 1 hour just looking on data sheets to understand what is our best substitution. And I come across with this one, the VP and VN MOSFETs. They are very tiny and take the place of those ones. And then because it's taking a lot of time to edit the video and I don't have too much free time, believe me, I'm a full-time job and then full-time dad at home when I'm in the evening, only myself and my little boy. I go and I did few streams. So here it was when we change capacitors, because we found out also that the power supply had a problem, and I was hoping that in that evening I can also finish everything on this amplifier, but actually I was happy that I managed at least to fit, because I needed to give also few drill the case. So let me find the footage when I was drilling the case over there. So you can see here I needed to do few holes because the new capacitor, there was not that much thick on diameter, and I needed to drill some bits in order to fit them in. And yeah, was a bit of hard work, that one, but finally I managed to put all the capacitors in. And this is the second stream which I did on this amplifier, and I needed just to install the bridge rectifiers over there. So you can see one is already installed. And after I installed, I measured the voltages to make sure are all correct. And let me find the part when I was measuring the voltages. So here is the part when I turn on the amplifier, and was everything fine, nothing blow up, and I just go ahead and measure the voltages to make sure that everything is okay. And I can see here I was measuring the voltages, and everything was perfect. So 58 volts on the positive side and 58 volts on the negative side. And also, I managed to change all the capacitors on the speaker protection circuit, because also there they were very old, the capacitor, and need a change. And then I come with the last stream when I installed the amplifier inside the case, because they are sitting in these two parts over there. You can see here I already installed the amplifier in place, and on that evening also we had calibration to adjust the bias perfectly, to adjust the DC offset, to make sure there is no DC present on the speaker output, and everything was nice and smooth. And we had also a sound test. And if you don't watch it yet, all these videos, if you get a chance, please have a look, like that you're gonna understand how much work I put on this amplifier to repair it, to restore it, to bring it back to his glory. Now let's have a look online for some specs about this amplifier when we're gonna run the measurement to know what to expect from this amplifier. So here we go, this is what I find so far the best things to know about the specs on this amplifier. So it says that the power supply consists in two 1.1 kilowatt class toroidal transformer and a total of 160,000 UF capacitors. And if we go here, these are the specs of this amplifier. So on the output we need to expect like 100 watts into 8 ohm per channel. So it's 100 in one channel and 100 in the other channel. And with the frequency operation between 20 Hz up to 20 kilohertz. The input sensitivity says that is 1 volt and 22 kilo ohm the impedance. It says that the total harmonic distortion factor is 0.05% or less. less from 20 Hz up to 20 kHz in 1 watt power rated output. So we're gonna maybe look on that one. I don't have the best equipment, but we can have at least an idea how it performs in distortion. Frequency characteristics looks like it will gonna be from 0.5 Hz up to 100 kHz with minus 3 dB on the edge of the bandwidth, and then at 1 watt output rate, 20 Hz up to 20 kHz, it will gonna be a loss of 0.5 dB. Signal to noise ratio should be 110 dB. Rated load impedance, so this one can drive speaker up to 1 ohm, and a damping factor of 120 at 1 kHz. Slew rate about this amplifier is 80 volts per microsecond, and the power is 100 VAC. I think this is talking for those that are exporting to US, I believe. 50 or 60 Hz. Power consumption is a 610 watts maximum idling. Now, let's go to my working bench and try doing some measurements. Alright, so let me explain what I have here on the table. So we're gonna measure only one channel at a time, because this amplifier is a dual monoblock, has separate power supply for each channel, and the output, they don't like to be here at the end tied together. So if I need to measure the same both channel in the same time, I'm gonna short the ground over here, because this one amplifier looks like after the output is not connected straight away to the ground, because has a star ground inside the amplifier. So if I again connect this short, I'm gonna make a ground loop through that ground star on the amplifier. So that's why I was trying to do some measurements in the same times, and they look not okay. So then I realized that from here to here, if I was measuring with the resistance mode, it gave me a little bit of resistance that the wires, the cables they have. So that's why also for signal, ideally should be to have the shortest wire possible for running this kind of measurements. But because the amplifier is quite huge, I don't want anymore to bring my dining table over here. So the amplifier is just sitting down over there, and I run cable in the table like that. I'm gonna use to do these measurements. So we have my signal generator over here, which I'm gonna use to inject signal. The frequency, we're gonna start first with 1 kilohertz to see the power, if it's matching 100 watts, how much it's saying on that specs on it. And after that, we're gonna do frequency response. So we're gonna start from 20 hertz up to 20 kilohertz to understand if it's losing any dB. If it's still in those specs, it says that it will gonna be rated at 1 watt power on the output. We should have only 0.5 dB at the ends of the bandwidth. So yeah, let me set up everything, power on the amplifier, turn on over here, bring the oscilloscope on the screen, and we're gonna start the measurements. Alright, so you can see here we have the oscilloscope. Then this one is my signal generator. It's already set up to 1 kilohertz. Here I have my dummy load, and I can see that the oscilloscope is connected to my dummy load in order to measure the maximum power that this one can do. So now I'm gonna go to increase the amplitude, because now it's at 10 millivolts, and we're gonna watch out when the signal will gonna flatten it. So we need to watch out when this line will gonna flatten on the top and bottom. So let's increase. The specs will say that in 1 volt we should have 100 watts, but let's see how much it can do it. At 1 volt we have 25 volts RMS. So we're looking for this number over here, because this is our output voltage. So 25.5. Let's switch it off and do a math. So we're gonna do 25.5 squared, so multiply it to itself, and then divide to our load, which is 8 ohm. So at 1 volt is give us a power of 81 watts RMS into 8 ohm. Let's go now to see the maximum that it can do. And now we're gonna go until we see the line flattening. So keep going in power. And the flat line is just over there. So we have 34.8. So now let's see the maximum power that can do this amplifier, and I was putting in 1.3 volts RMS. So we had 34.8, square it and divide by 8 ohm. So we are getting 151 watt power RMS into 8 ohm. That's really insane. Poor class A power. Now let's see if the other channel do the same numbers. So I'm going to change the oscilloscope to the other channel over here. We are going the same to see on 1 volt if we get same 25 volts on the output. At 1 volt I will gonna stop this one. We're gonna have a look the voltage output. So here is 1 volt, so we have the same 25.5, so it's properly balanced. So let's now go to the maximum power that can do before it's flattening the line. So also here is flattening in about 35, 34.8. So yeah, is doing the same power also the other channel, which is really cool. And just for 1 minute of running, just to take this to measurement, have a look those resistors how they look. They look really toasty. Also the heatsink look really toasty. Everything there is toasty. Yeah. Imagine 150 watt power dissipated on those resistors. It's really crazy. The resistor is just only 50 watt, so I push 3 times power in them. Actually, no, are 100 watts. So yeah, they withstand to 150, but actually they are rated only to 100 watts. Now to run the frequency response, I need to set up the signal generator input signal when I'm gonna get output of 2.84 to get almost 1 watt power into 8 ohms over there. So let's do that. So in order to get these measurements more accuracy, because we don't want to see any changes neither over here on my multimeter, because I connected the multimeter to the input. So we have 109 millivolts, and we need also to pay attention where is my mouse pointer over there to have 2.8. So it looks like in 20 hertz, and also we look also the frequency. Yeah, so it looks like in 20 hertz we're losing a bit because we should have 2.8 RMS over there, and in case of dropping or going up, we're gonna compare with my multimeter voltage, right? If it's dropping on the multimeter, this means we're gonna drop automatically also here. So let's go more. So here we go. We increase a bit of the RMS on the output. On 40, we are already in 2.8. So yeah, it's like 0.5 dB losing for the at the end of the bandwidth. So here we are staying flat, input and output still the same voltage. Let's give an auto set on this one. 90 hertz still okay, 100 hertz everything fine, 200 hertz still everything fine, 300, 400 flat, 500 still flat, 600 still flat, 700 hertz still flat, here still flat. Here is our 1 kilohertz, and we have flat until here. Now let's do the 2 kilohertz is flat, 3 kilohertz it is still flat, 4 kilohertz is still 2.8, 5 kilohertz still 2.8, 6 kilohertz is still 2.8, 7 nothing change, 8 nothing change. Actually looks like we drop on our input signal, so I didn't notice where that one changed. Let me go back. So here we are dropping, so my signal generating is losing, or maybe my multimeter doesn't read anymore to that frequency accuracy. So yeah, even this one is not a good way, and I can't connect another oscilloscope because I have the same ground, and this one doesn't like to do a ground loop, this amplifier. So we're gonna have a look on the output then. So let me go back to, was in the 7, right? Yeah, 7, and we have still flat, 10, 8, we are still flat, 9 kilohertz, still 2.8, so we are going flat. So far, so good. At 12, we are still flat. See, already my multimeter is not measuring anymore at this frequency, the AC voltage. At 13 kilohertz, we lose all the signal. The multimeter can't measure anymore this frequency, the voltage present on that frequency. Let's go to 15 when we are increasing a bit. So I'm not sure if the output of this one is increasing. I'm gonna run quick a measurement then straight away with the oscilloscope attached on the output straight away from this one to see if it's changing also there like that, because we already 1 volt, 0.1 volt RMS more at 15. Let's see at 20 hertz, we are there. 20 kilohertz, sorry, we are 2.94, and let's see 22, and then it says that goes up to 100 kilohertz, this one. So let's see if it keeps holding that signal up to 100 kilohertz. So we are about there, 100 kilohertz over here, and it's losing 0.3. So yeah, it's like right on the specs of the manual. So let's see where we have 2.8. 2.8 we have here where it's 79 kilohertz. So this amplifier we're gonna do very nice high frequency. We're gonna keep it really flat and nice, and yeah, that's cool. So I connected straight away my signal generator to the oscilloscope because I want to see if anything changing on frequency, which it was above 5 kilohertz. So now we are in 22 kilohertz, and now you can see the signal is 110, and if I go now to 15 kilohertz, the signal is 110 millivolts. If I go to 10 kilohertz, signal doesn't change, it's still the same, 110. And if I go to 5 kilohertz, signal stay the same, 110 millivolts. And if I go down to 100 hertz, we can see the signal is still the same, 110 millivolts. And if we go to 20 hertz from where we start, definitely my signal generator is working perfectly, still 110 millivolts on the output. So this means the amplify a little bit from 5K on above, like 0.100 millivolts RMS on the output more, because we reached to 2.9 and we set up to 2.8 to give us 1 watt power RMS, because that's the specs that say that we need to measure this frequency response. So now let me set up to spectrum analyzer and see the distortion, if it's changing anything or not. So I'm going to take just few samples, maybe 1 kilohertz, 100 hertz, 5 kilohertz, and 22 kilohertz, and I'm gonna compare the samples with the output from the amplifier. So now I'm taking some samples straight away from the signal generator, because involve cabling over here around, and we need to know actually the how many distortion we have before injecting this signal on the amplifier, and like that we comparing with what the amplifier put it out on our dummy load on speakers. Let me put it on 100 hertz, and we're gonna start from there. So I'm in 100 hertz, and I'm gonna just do auto setup, and we're gonna see which samples we are getting. Let it move a bit, because you can see over here we have the minimum and max percent of THD, total harmonic distortion, that we are looking for, and we're gonna understand what's the minimum that it catch and maximum what it catch. So it looks like it catch between 0.03 up to 0.2. So I'm going to take a few pictures on this one. So now I'm gonna stop this one, and then I'm gonna set up to 1 kilohertz right now. And then I'm gonna press auto setup. We're gonna see also here the minimum and maximum what is getting. So let it run a bit, because it's taking samples. So you can see here on the top is counting the samples, waveforms that is taking and acquiring, and then is giving me the minimum and maximum, the distortion that is comparing all these samples between them. So let me take a picture. So it looks like it's between same 0.03 to max 0.2. That's the number that we are looking for. Now let me stop it, put it on 5 kilohertz, and I'm gonna do an auto setup. Let's see what is occurring. Here it looks like the minimum looks like it get down to 0.3 and maximum still in 0.2. Forget about the number behind of those ones, so we are interested on those first numbers. I say it's not the perfect equipment to do this one to the amplifier, but at least we can have an idea if anything come over those numbers. So it's pointless to take any picture because it looks like are the same readings. And then let me stop and put to maximum. I say 22 kilohertz. Let's see the minimum and maximum what is getting here. So I can see here is a bit more higher. So here we have between point, look like it's going down. Let's see if it's going more down than that. But definitely the maximum is a bit higher. So yeah, we have a bit of higher. So let me take a picture to know on the maximum frequency what was the distortion. So why in high frequency is more distortion? Because it starts picking up noise from the switching power supplies which I have around the desk and everything what might induct noise on the signal. So that's why if we go more higher on frequency, let me just give you an example around 100 kilohertz to see what it's doing, to see how it's picking up more noise. So let's just, this one will not test it with the amplifier, but just to make you aware that at higher frequencies we can pick up more noise because there is switching mode power supplies around here that are powered on and they are inducing noise. So let me do an auto set and have a look here. See, we are going more high on distortions because definitely there is more noise around of this. Now let's connect back to the amplifiers, to the output oscilloscope, inject this signal in and see if those numbers are changing. So I can see I connected the output from the signal generator to the input of the amplifier and the oscilloscope is connected to my load. See this wire and this wire that goes to the load. So now we are measuring the output distortion that comes from the amplifier. So let's see if the number's changing. So I set up already to 100 Hertz because I start with that frequency. So I'm gonna go in auto set and let's see the numbers of distortions. We are looking for these numbers over here and we're gonna compare minimum and maximum what is getting over there. So we are on 0.001, 0.003. So let me see on the picture that I get them to see what was. Specs will say 0.05% distortion. Okay, so let's now move to 1 kilohertz. So I'm gonna press auto set and let's see what we are acquiring to 1 kilohertz. 1 kilohertz, we are looking same for minimum and maximum over here, and we are in about the same 0.02, 0.03, more than whatever was without the amplifier on the line. So I can see here the numbers are very low. So yeah, the distortion is not high. So let's see now at 5 kilohertz what the numbers will look like. So let's take more waveforms there to analyze and compare them and give us the minimum and max over here. So we are standing on the same numbers over there. I can see also this one that is changing very fast. Minimum and max that we need to have a look on there on this section of THD looking the same. Here it's a bit more higher. As I say, while you are going to high frequency, picking up noise around the area of switching mode power supplies or something like that. So 0.03 now on the top what was before. And now let's see at 22 kilohertz what is doing. So see, already in 22 kilohertz we have these two spikes over here that definitely is catching some noise around. We are in the same voltage output, so we don't touch nothing about that one. So we are still in 1 watt power measuring. I can see here definitely more noise we are picking up now because it was 0.00 something, now it's 0.2. So definitely while you are going more high, whatever's in the cable, other noise is picking up from the switching mode power supply, we're gonna be throw it on the amplifier and the amplifier we're gonna boost that signal more high. So that's why we have also these two spikes over here, which is one around 40 kilohertz and the next one is around 63 kilohertz. Yeah, so those high spikes are some other picking up noise, and then actually the signal, our signal is this one over here. I can see it's above 20 kilohertz. So this is the frequency bar down there. So this is the signal that actually we are injecting over here. And this one is random noise, floor noise, call it, the up and down things over here. And then it's picking up some other two noises over there, which, starting to be maybe some switching mode power supplies or whatever here around. Overall, the measurements looking really good. I'm really happy with the results of these testings. So yeah, 150 watts RMS power into 8 ohm pure class A. It's quite a lot, and it's quite nice sounding amp, because definitely the sound of a class A amplifier will be definitely different than class A, B, or on a class D amplifier. You're gonna feel it. That how to explain? So you're gonna feel the bass who is playing the drum is just in front of you. You're gonna have like the guitar. It's like natural sound of the guitar is not coming like when you listen to a class D amplifier or a class AB. Don't get me wrong, also class AB, they sounding nice, but you can feel on the sound that is missing the intensity of the power. It's like missing something always over there. So that's why how it sounds, I listened to it also after my last stream. I set up my full range speaker and I play some songs that I test also other amplifiers with that song, and definitely I know how that song has a natural sound, and believe me, this amplifier do the same. It's really a pure sound. And now that I have the schematic, I'm gonna spend some hours in the front of my computer and I'm gonna design a pair of PCBs like that. Maybe, who knows, I'm gonna build one for myself, because I really like how it's working. I really like how it sounds, and with the measurements from now, I'm really impressed. I'm pretty sure Vishal will gonna be happy with the amplifier, and I can say a big thanks to him, because he trusts my work and he trusts how I'm looking after the amplifiers. Whatever, if it's not mine or it's for someone else, I look into that amplifier like how is mine amplifier. So I want my amplifier to sound good, to perform good, even if it's not my amplifier. It's not like, okay, I found the components that were burned out, like those transistors, just I put in the other new transistor and that's it. I don't care then run a measurement to understand if it's really worth the amplifier, it's really sound how should. No, I care about it, and I'm running all the tests to make sure when the amplifier goes out from my house, and when someone listens to this amplifier, they were gonna say, yes, it sounds really good. And if my come discussion between Vishal and the other people who fix for you the amplifier or something like that, definitely you're gonna mention, yeah, I have a guys that I am trusting on him, and if you have something to fix, definitely I can help you with. And before closing also this last part on the amplifier, I want to say a big thanks also to my channel members, which are Laptop Fix YouTube channel, JFix YouTube channel, Rusty Rose Repair YouTube channel, and Grandpa's Bench on YouTube. He didn't start the channel, he told me that he was gonna start at some point, but I'm keep waiting for his content to see with what will gonna come up. Then, if you are interested in all the tools that I'm using around my working bench and this equipment that I run these measurements, check the links on the description down below and you're gonna find all of them. If you enjoyed this video and if you want to watch all the series, I'm gonna put also the links for those videos on the description. Have a look from the beginning till the end, how much work I put on this one, and maybe you're gonna understand how I look after an amplifier. And if you are new watching this video, don't forget to subscribe to my channel, activate the notification bell to don't miss my next videos. And I hope you enjoy, all of you watching this video, so it's important for me to give me a like. And also, if you want to know more about this amplifier and about other things, I'm really happy to read all the comments, and I'm definitely reply to all the comments that they are coming to my video. So I'm taking my time also to answer to those comments. So if you drop a comment, will not be just drop it there and I will not read it. I'm gonna read it and I'm gonna reply to it. So have a good day, and Merry Christmas to everyone. Bye bye now.